Hi, so this short video is just showing you how to demonstrate that light travels in rays, if you like, straight lines. And to do that, it's easy to use a laser pointer. Now, at this point, I should just say, I know these things are really common in school, just for pointing at out points or whatever, but if you do use one in the classroom, you will need to do a risk assessment. And I recommend looking at CLEAPS, the guidance on which lasers you should be using. They have some suggestions for risk assessments and where to purchase suitable educational lasers from. This is a red laser that I'm using. I don't know if you can probably see on the desk there, if I shine it on here. Low power, less than 1 milliwatt red laser. Now, what I've also got here is, I know it says iron filings on this little shaker, but it isn't. It's actually chalk dust, as you can probably see there. I've probably got it all over myself because I've been playing with it. If you shine a laser beam, I'm going to shine it on this container here. You can see it just forms a dot. We only see the laser beam where it interacts with matter. It interacts just there. This is the source. Okay, this is where it interacts, and then I see the reflection in my eye. It's one of the reasons you have to be careful with laser beams, because if that reflection is from a mirror or something like a ring, which I've taken off a ring to do this experiment, if you get a direct reflection in your eye, it can be very dangerous. So this we only see it when it interacts with matter. We can't see the beam there. We can't see the laser light going from here to there. So one way we can see that is to get some chalk dust and to drop this chalk dust over the beam. Now, this doesn't work super well in the light, and with me just moving it with my fingers, but as the particles of chalk dust move through the beam, the laser light is able to reflect off, and we're able to see the beam as it travels through the air. So I've done this better in a dimmer light and with chalk dust using the shaker coming out like that, which I'll show you in a moment. It's a really good way of demonstrating that light travels in straight lines. So while we have the laser out, it can be useful to show a straight line beam through water, especially if you don't feel like making a mess with the chalk dust on the floor. Again, we're in a darkened room, and if I shine my laser beam through this water, I'll just move that bottle out of the way just for a second, you can see the beam quite clearly. Obviously nothing in the air, because there's nothing for it to reflect off, but as soon as it goes into the water there is. Now I'll just give you a tip. With pure water this doesn't work super well. You can just see the beam normally with water because there are tiny air bubbles, for example, in water that the laser light will reflect off. To make it work better, that's why I've got this bottle here, I've just put a squirt of hand wash actually in there, giving it a mix, and the particles of the hand wash of the soap in there and the air bubbles give it something to reflect off, so we can see it really well. It probably works quite nicely just with the bottle of hand wash itself. There we go. Which is quite good. If you haven't got a hand wash to hand, you can literally use almost anything really that'll go in the well. I've done it successfully with a drop of milk. You could use a drop of washing up liquid, that would work really well. A bigger tank obviously would work well as well. But again, we're just showing the straight path of light and the need for light to have something to reflect from in order to be seen by our eyes. So again, a useful little demonstration using the laser.